Hi, my name is Kevin Donnell. I'm an experienced design lead here at Infosys. What we have here is a 3D printed aircraft jet engine. It's an open source model that we've made a couple modifications to. This is an IoT use case for our artificial intelligence platform with large industrial assets. Myself and two other VR experts spent the last week and a half developing not just this model, but an entire augmented reality overlay that goes along with this experience. So with this 3D printed turbine, we have a couple sensors on board. There's a strain gauge sensor to measure the deflection of the plastic. There are temperature sensors to measure the temperature of the combustion chamber, where one of the two engines are lying. And those two engines on board, each of these two engines drive the separate spools on board of this engine. So all of these sensors are collecting data, feeding this information up into the cloud, and then we're able to grab that information from the cloud with the Microsoft HoloLens and display that information on top of these jet engine turbine in a contextualized manner. The strain gauge will show a blue-green heat map overlying the deflection of the plastic throughout the casing of the engine. The temperature sensor will give the user a red-orange stratification of the temperature through the fan section, up through the combustion chamber, and then down into the turbine. And the user is also able to get information on speed throughout the different blade sections. Additionally, there's a one-for-one digital representation that is built of this exact same model, which is a digital twin of this smaller 3D printed jet engine turbine. We're able to leverage prognostics, scroll out 1 to 2 years out into the future to understand what this turbine would be experiencing if we continue to run at this specific duty cycle. We can then break down this larger engine into very specific components, all of which make up this very complex model, and understand root causes of specific failure points that we might be able to determine 1 to 2 years out. We can then use that information of this knowledge model to teach people how to go in and service large assets like this turbine. And so this can be applied to many other large industrial assets. Anything that has a surplus of sensors, information coming off of it, we can introduce this new way of how these things are going to react downstream and better prepare for servicing them in the future.